Hello there, in today's episode we're going to be talking about flying in my game. So I have a feature in the game. By the way, the game is free to download for your Android devices and you can just go ahead and download it for free. You can start the flying mode and wherever you look at, you'll go there. It's as easy as that. So if you just use the joystick, I am using my keyboard because that's kind of be easy to both use the joystick and rotate the camera at the same time. And wherever I'm looking at, I'm going to go there. As simple as that. So let's get into it. The way I'm initiating the flying is pretty easy. It's just an event that's a custom event. So you can just type in custom event. It's called fly in my game, or F on my keyboard. I'm working on a mobile game, so I need some buttons on my HUD, so this one initiates the flying. It casts to the third person character and the object is player character, and then it calls out the fly custom event. And that comes in here. So if you double click on it, it comes in here. We need a variable, so you can just add a variable here. The variable is going to be a boolean, and the default response will be false, because by default the character is not going to be flying. And then if the variable is false, it's going to go check the Rust box in the game, which you don't really need because that's the currency I'm using in my game, and another currency. And then if everything's fine, if all the checks are complete, then it comes here. The way I initiate it is by using a jump, so the character doesn't get stuck on the ground, or doesn't create some really weird bugs. That's something that's really important to prevent rough situations. And then a little bit delay to let the character jump to the sky, and then we are going to set the movement mode to flying. This is something that's pre-built in our engine, so you can just go ahead and use it. So you can get character movement and then set movement mode. This one right here is pretty basic stuff, to flying. Then I have two other particles that I had already created. You don't need those. Those are the particles that just are extra details for my game. And then this is the important stuff. Make sure the variable is set to true, because we are checking it here, right? So it must be always correct. And then this is again another extra detail for my game, because I want the camera to I want the character to always look at where I'm looking at with the camera. I don't want the camera to rotate around the character. So character movement, again this one, set use controller desired rotation to true. And then another extra detail for the camera to zoom out a little bit, so the player is going to see everything around them. And this is another extra detail again, and that's it. So all we did was jump, set the movement mode to flying, and set the variable, and use control desired rotation. These are the important points in this. So now when you do this, you can fly around, but you can't change the altitude. So you can just go on the ground while you're flying, or just drifting in the world. So how we can fix that? I have something else called altitude change, and it's based on event tick. Both event tick and when the character is using the joystick. So when the player is using the joystick, the scale value is more than 0, and that makes the and if that and flying mode is enabled, again, as I told you, we are setting the variable here. If this is true, then in the event tick it will all happen. So before this, let me explain something else. It can get a little bit complicated, so I have to make sure that everything is correct. In the first check, when the flying is false, when the character is not flying, then we initiate flying. When it's true, means that when the character is flying, when the player is clicking on the button again, the character should be going down or come back to the walking state. Or maybe it's not a custom event, maybe you want it to be based on something else, I don't know. But that's when this variable comes in handy. So if the flying is true, then we have to shut it down. The way we do that is just grabbing the character movement, set movement mode to back to walking, and make sure that the variable of flying is again false, because it's not going to fly anymore. And this is old stuff. Use controller desired rotation is something we already changed, and we had to set it to true, but now we don't need it anymore because we want the camera to rotate around the character, so we have to set this one to false as well. And that's it. For changing the altitude, we have to do some stuff. A custom event called altitude change, so custom event type altitude change, with an input of float. Just I shouldn't have done it. Just click on this add button and then make sure this is a float and type in scale value. This will be set in the input section of the game, so we're going to be setting that later. We have to check if the character is flying, so again we use flying variable, and you can just drag it in here, get flying variable, and when you want to set it, you can just set it like this, true, false. And then we have to come up with a branch. If the character is flying, then we have to go trace some stuff. That's pretty important, because if there's nothing in front of us, how can we know where we are headed? There should be something in front of us, and we should be able to trace against it to get the location of that point. That's the point. Okay, how can we trace it? We started trace by the follow camera, so the camera that's following the character, or if you're using the first person template, the camera that's like in the head of the character. So get world location from follow camera, get world rotation, and we need to change the pitch value a little bit, minus like add an 8 to it, so plus 8. These are both the same, so you can just subtract it with minus 8 or add an 8 to it, and this one goes into the pitch or Y value. Z and X are the same, so make rotator and then get forward vector. The way the reason I'm not showing how to get this stuff is because they're all the same, so we can just type in what you see here and get the blueprint, get the function out, and then you have to multiply it. You can just type in this, multiply and multiply, and then go for something really big, something like 20,000 for every axis, and then we have to add, like add, and after get world location, we have to use another add, and not another add, we have to add this to this, like so. So we're getting the next point location, and then we have this world location of the camera. We'll add these together, and that's the end. The start is the camera's location, as easy as that. So camera, get world location, and that's the start. Adding these two together will be the endpoint of line trace by channel. The trace channel is visibility, like the default stuff. But you have to make sure that everything that's in the way, even the blocking volume specifically, or the sky, because sometimes you're flying, and if you want to go higher, you have to look at the sky if you don't have a ceiling or anything. That blocking volume must be reactive to the visibility channel, or in other words, I can't remember they either must overlap with visibility or block the visibility. And trace complex must be enabled. Okay, so if that hits something, then we have to do a branch and break hit results, and this is our location. So we don't need the full location, we only need the Z value of that location to compare it with the Z value of our character, or not the character, the camera. If you're using first person character, doesn't matter. If you're using third person character, chances are the Z value of camera and characters are different, but the player is looking at the game, seeing everything from the location of the camera, so we have to go ahead and use the camera's location for everything, for end and start and comparing stuff. So here we have to do a minus or subtract, and we are subtracting this by the world location of follow camera. We have to break it because we only need the Z value, and then Z value comes all the way into this. So this minus this. It's just more tidy, that's why. And I went ahead and tested a lot of stuff and found out that these are the values I want, so I just clamped everything all together. So map range clamped. Range A is minus 1800, range B is 1800, and outrange A is minus 1, and outrange B is 1. And this will get multiplied by the absolute value of scale of the joystick. So if the joystick's in full motion, it will output 1. If there's nothing happening, it will output 0. So it means that the absolute value, we don't want minus 1, we want the minus 1 to work and as 1 as well, so we need absolute. So you can just type in absolute float. This will make sure that everything is positive, we don't have any negative value. And we just get an absolute from scaled value and then multiply it by this and set it to a new variable called scale value. Okay. Oh, that's my cat. And then we have another value called altitude scale value, which I don't know why I have set it in here, but just to make sure that everything is working correctly, I'm not touching it. So scale value is the variable we're going to be using to change our altitude later on. Okay, this is this part, altitude change. So where are we using it? Where you're using input axis forward, or if you're using something else. Where you're using your joystick movement, or if you're using keyboard, you're using the W to move the player forward, or S to move the player backwards. You have a function called add movement input. And that's got some scale value that's coming from the input axis forward, or if you're using another function, there's always some axis value that's always between -1 and 1, or -5 and 5. This is something that you have to create, but if it's not -1 and 1, then you have to change the values here as well. Just go ahead and test the different values and you'll get the best values there. So you can just use the altitude change, just type in altitude change that you already created and make sure it's connected after the add movement input. And the good thing is that if the character is not flying, it doesn't do anything. Okay, so last step is the event take, and we're just seeing if the altitude scaled value is true, which in my case it's always true. I never set it to false, so whatever. If the character is flying, instead of this you can use the flying as well, but I don't know if that's gonna work pretty well. Let me see. Yeah, apparently I'm not using it anywhere, so you can maybe just go ahead and replace this with the flying variable. You know what, let's do that now. So flying, replace flying with this and compile, and we'll see what happens next. Okay, so here you have to add movement input, so just type in add movement input, this one. And the world direction is gonna be get control rotation, get up vector, so just type in what you see here. X value is the X value, Y is 0, Z value is Z value. And the scale value is the variable we've set. Okay, so let's see if it works with the flying. Yeah, it just works the same. So we don't need the variable, apparently. It's just something that's left there. And everything works pretty well. Okay. Yeah, and that's it. It wasn't easy, it's a little bit complicated stuff, but you can get it done pretty easily. So let's see if I don't even use event tick, what happens then? Yeah, okay, it doesn't work. So yeah, this is what makes sure that the character is moving towards what we see. So scaled value is something that we had already set up in here with this pretty complicated stuff, not pretty, a little bit complicated stuff in here, and the world direction is X and Z, and that's it. And you got it. That's it. If you've come so far, congratulations, and I wish your game to be a huge success for you, and I wish you a great day. Bye.